All right, so now for this one, it says the function c of m equals 15 minus 10.5 m approximates the temperature in degrees Celsius at the altitude m miles. So the capital C is for Celsius, and in this particular case, the temperature is dependent upon the altitude in m miles. All right. The diagram and the relationship is this function. And the diagram shows the altitude in miles for an airplane, or of an airplane, t minutes after taking off, where 0 is less than or equal to t and 0 is less than or equal to 30. And so the first 30 minutes after takeoff, where c of m of t, and then we're asked to evaluate at 30 minutes. So this is like, remember our first example where we said Kelvin to Celsius and then Celsius to Fahrenheit? And so to do this, we basically do the same thing. So I'm going to label some things. First of all, I'm going to label this one. This is C of M. We'll do that in green. This is actually M of T, which is 0.2, right? So I'm just going to jot that down so you can see it a little better. M evaluated at T, where T represents the minutes. And that's the miles, right? So this represents, okay, so this is like time. And M represents the minutes. Actually, no, M represents the miles. It's the height over time, right? So this represents the miles, or the height, or the altitude. So how many miles is the plane off the ground after so many, and this is time, this is minutes. And it basically climbs 0.2 miles for every minute, t. All right, so then what do we do? Well, let's just start with our equation. We're going to say C of equals 15 minus 10.5, and wherever there's an M, I'm going to put parentheses. And so this would be C of M of T, and then this would also be M of T. Okay? All right, cool. So now we're going to say C. I got to make my C a little bit more like a C. C of M of T is equal to 15 minus 10.5, and then I'm going to put something here in parentheses here. What's M of T? 0.2 times T. And we'll probably need our fancy calculators. Let me fire mine up here. We're going to do some decimals and stuff in a second. So I'm going to say C. Shoot, I hate when it does that. So now what I need to do is, in the next line, I'm going to multiply this negative 10.5 times the 0.2, right? So I'm going to say negative 10.5, it's the same time, it's interesting, times 0.2. So that'd be negative 2.1. So let's see if I can actually oh, this is very frustrating. So then in our next line, what we're going to do is we're going to say C of, in parentheses, some stuff. 15 minus 2.1, and I'm just going to say t. Okay, so that is your C of m of t. Alright, so I'll leave that up there for just a second for you guys to kind of copy that down. I know some of you guys were trying to put that in your calculator as well. So then lastly, what they want us to do is just evaluate this. Oops. Let's just do this color. They want us to evaluate this at C of m of 30, which is equal to 15 minus 2.1 times 30. Now, the cool thing about your calculators is it'll automatically do order of operations. So we could literally just put this in all in one thing. I could say 15 minus 2.1 times 30. Well, bam, with the bacon sizzle. And I get negative 48. So I would say, oh, it's the calculator software. That's funny. So then that is C of m of 30 equals negative 48. Degrees. So what does that mean? That means that after 30 minutes, the temperature is negative 48 degrees Celsius. Okay. Now you could think anybody ever fly on a plane, you could see why that's important, right? Because you don't want to be at negative 48 degrees Celsius in the plane, so they have to heat up the plane and they have to maintain the room temperature, so they have to figure that out. That's another example of how this is used in the real world. So I'm going to leave that up there for you guys for a second, and then